As you know, K-means clustering is a method of vector quantization originally from signal processing that aims to partition an observation into K clusters, in which each observation belongs to the cluster with the nearest mean, serving as a prototype of the cluster. So in this video, we will learn about K-means clustering and its hands-on in Python.
So let me walk you guys through what exactly is supposed to be done for that project. So if we break that thing down, so let us say we first call a data processing unit. So in this data processing, in this Portuguese bank, the first thing you guys need to check is all the variables or all the columns that you have. Okay, the columns are making sense or not with respect to your target. In this case, indirectly, what you can do is you can do your correlation plot or something like that to check it out. Okay. Next is you can find out which are the columns which are having maximum number of zeros. Or in this case, I think you are having unknowns if I'm not wrong. Correct? Yeah. So you can find those out. If in case this is in huge number, find out the total number. So let us say for one column, out of say 100 rows, 60 of them are unknowns, for example. So this is, I feel, is a huge amount of number. So you can say anything about 30-40%, which is completely unknown data or junk data. You can go ahead and do some kind of replacements. So are we aware about basic replacements like mean, median, and mode? Apart from these three, my personal favorite and logical one is your median one. So you can go ahead and replace all the zeros with that column's median. Okay. So before doing the replacement, you guys would have generated the dot describe function, correct? So dot describe function basically gives you two things, your mean and your standard deviation. And post replacement, you again generate the dot describe function. Check out the mean and check out the standard deviation. If the difference between these two tables is not much, I can say not much in the sense, it is well controlled within 10 to 15%, not more than that. We can say that we have cleaned up the data. If in case you feel the difference is too much, you can, this is not a good technique what we have done. You can try with something else. Or if in case you feel zeros are not big in number, you can even remove them, not a problem. Okay. The next thing is the EDA part of it. So there they would have asked you guys to find out potential people who are going to turn up as a potential customer, correct? So in EDA, this particular data set is very popular. Why? Because we have got a lot of options. Yeah. So you can start with univariate analysis. Univariate in the sense, pick up one column and try to put plots onto that. Plots in the sense you can put a box plot, a frequency plot, or a histogram, a scatter plot. You can try to understand that way. And the good thing about this is you can give an inference. So for example, if you guys have put a box plot here on average balance maintained, have you guys done that? The average balance column is there, no?
Yeah.
Did you try putting box plot? Did you find out some weird thing about that box plot?
Yeah. Yes.
If you put that box plot, you will observe that
Outliers.
Yes. Even if you would have put age in that particular data set, you would have found out that there are customers who are more than 70 years of age, and even the outliers sometimes are going up to 90 also. So what we can do is we can give an inference here saying that these kind of customers, banks should not do a campaign on them because of the age. You don't expect a person who is 90 plus to invest in a term deposit. Yeah. So you can just give an inference. In average balance, I found out it was around 100K if I'm not wrong. So you can say or tell the bank that filter these customers out, do a specialized marketing campaign onto that. Why? Their average balance is pretty good. So investing 10, 15K should not be a big deal for them. Yeah. So this is called univariate analysis. If you want, you can go as deep as this, or if you want to just cover up high level, you can do that also. But I feel it's a good thing, spend 20-30% of your project time only onto EDA. Why? First of all, you will get understanding of each and every column like this. It will help you to do machine learning because it will help you to choose columns. Okay. Post EDA, so post univariate, you can go for bivariate. Bivariate was what? You can compare the profession with respect to your target variable. Correct? So you'll come to know a person coming from which profession, how much he's investing. So let us say I think we have blue collar and white collar and entrepreneurs and students and all those categories there, if you people observe that. You can find out easily from here that if in case a person is a student or if in case a person is entrepreneur, how many of them are turning from the previous marketing campaigns, how many of them actually bought the product. Yeah, so this could be a very good inference for future. So your client taking this data, a client can understand that in future, if a new customer joins me, let us say he's a customer, he's an entrepreneur. So you can find out that yes, they might be having good amount of money. It's a positive sign for them to invest in term deposits, something like that. It's not going to affect your accuracy in this model, definitely, but it's going to give you a good inference out of it. Yeah, so this is what I'm talking about, bivariate analysis. If in case you want to go beyond bivariate, you want to go for multivariate analysis, I'll give you one more hint. You can keep target variable as a row, for example, and as a column, you can keep multiple variables. And this target variable can be from your previous campaign and this campaign. And then let us say you say age, balance, gender, profession, a lot of things you can keep and observe the numbers. Did the numbers change? Is it a deciding factor or the numbers are similar? Something like that. So this is called multivariate analysis. I hope you people got it. Yeah. So this is going to give you a good amount of idea about what the numbers are saying or what the project is about. Next comes immediately your test and train split. So once you are happy with EDA, once you have understood all the columns and you are happy by keeping all the columns, if in case you want to remove some columns, give a justification and remove it. Post that, you start your machine learning part of it, wherein we start with say decision tree. Yeah. Then you record the accuracy. Definitely this will be an overfit model, 100%. So you do pruning over here. Yeah. Post pruning, record the accuracies, training and testing, both of them. Next, start with all other ensemble techniques. Do the same process, record the accuracies here. And if you remember last time I had shown you recall factor also. If somebody wants that way, put recall factor also, nothing onto that. Finally, plot a table or you put manually and choose the best accuracy out of it. That's it. That's all is your project about. Okay, fine. Are we good?
Yep.
Sweet, thanks. Yeah.
Perfect. If in case anybody is still confused about this, wants an extension, please do not hesitate. I'll be very happy to put a word to Abhijit or I think Shoaib, right? If I'm not wrong, sorry, Shoaib. We can put a word to Shoaib saying that we need a little extension. We can extend it by 1 or 2 days, not a problem. A genuine reason. Yeah, just in case. I'll be happy to vouch for any of you. Not a problem. Okay, so now moving on for our unsupervised learning. So last time I think I gave you guys an intro about what is unsupervised, what are different techniques we have in unsupervised. So just to brief it up, what we did last time, very quickly, I'll not take much time. So the only line of difference between supervised and unsupervised will be the target column. So once the target column goes missing, or once in a data set, even if the target column is there and you believe you don't want it, you can use unsupervised learning. I'll give you both the examples. So let us say in your banking data set that you have currently, okay? Or it's okay, fine, forget banking data set. Let us say we are having a data set where there are some features given to us. So it's an animal data set. And there are some features given to us, saying that if the animal has got 2 ears, let us say 1 tail, and he's furry, I can say it's a cat, for example. Or else if the animal is having certain attributes, it's a dog. Just an example. In this, so this is your target variable. In this particular data set, we are not sure because see, a dog can also have 2 ears, 4 legs, and they are furry and a tail. We are not sure about how authentic this data is. So if in case you are not trusting the target variable, you can ignore it, and you can take this through unsupervised learning technique like clustering to build our own cluster. So once we have got our clusters, we can name the cluster either 0, either 1, either 2. And we can understand on the back end saying that 0 will be dog, 1 will be cat, 2 will be, let us say, rabbit, for example. So this is one worst case where you can go ahead. Else, if your data originally does not have a target variable, yeah, what you can do is you can create a target variable using our clustering technique or some other techniques. And once the target variable is created, you can push this data to supervised learning techniques. Okay, so you can do anything you want. Sometimes people stop at clustering, they create clusters and they stop. Nothing to do, nothing to worry. Like it's a good thing. But if you want to do machine learning on that, do not stop, move on, push it onto our ensemble techniques. Why? Because we already have now targets. So we can make a good prediction model. Sometimes I have seen people going on Google and reading blogs. The people who's writing those blogs, they are very, focused only on unsupervised learning. So sometimes this information is little missing. So please try to, think in this way, saying that we should not stop here. There are 100 possibilities even beyond that. Okay. So this is one thing. Now, under unsupervised learning, there are many techniques. So the first and the most simplest technique that we are going to see is clustering. Post clustering, a hybrid of clustering, we are going to see what is hierarchical clustering. After that, we are going to see a technique called principal component analysis. So this is, I think, what is covered in your course. Something extra from my side, I will show you guys factor analysis. Plus, I will show you another technique called SVD, singular value decomposition. Yeah. So this one, anyway, it's going to come under recommendation system module after 2 or 3 modules, but it's okay. Why to wait? I will show you this also. So I'll show you all the case studies one by one. Okay. So I think we will do these two once our project week is on so that we don't waste much time now. And these one, we are going to cover one by one. So I think last time we did clustering. So everybody remembers clustering, or do you want me to repeat once again quickly?
We remember that.
Remember? Perfect. So let's move on directly to the data set now. So, yeah. So as usual, these are our libraries that we are having. And what do we have here is, we have got, give me 1 minute, guys. This is hierarchical. Okay, so this is my standard libraries that I'm going to import. So one very frank question to all of you. We are comfortable with libraries and Python right now, at least all of us?
Yeah.
Okay, good, perfect. So if in case you want me to explain something, please stop me. Nothing wrong with that. So these are my standard libraries. Next, what I'm doing is I have a data set with me today, wherein this data set is coming from, I think, one of the researches done onto some depressed patients, or basically some patients. And then they are trying to find out certain matrices within psychiatry on depression. So let us say this is value called simplicity, fatalism, depression, adjusted. So there are some values given to us and there is no target value. So now we want to classify whether the patients, they are into no depression state or high depression state, something like that. Or if you have one more, let us say we say K is equal to 3. That means you want 3 clusters. We can have extreme depression. If you have one more, we can have no point of return depression or something like that. So if in case we have K is 4, we can go ahead with a classification like this. Yeah. So the first thing which triggers that this is an unsupervised learning problem is because of absence of target variable. As simple as that. Okay. Good. So this is my data set. This is my business problem. So these guys want to automate this particular report, saying that when the computer generates this, along with this computer also should generate me a trigger saying that this is no depression or this is yes depression, something like that. This is my total business problem. So what we'll do is okay. So the first thing which we don't need here is our ID. It's of no use to me. This has nothing to do with our output. So the first thing we are going to remove is our IDs. So I'm just dropping it. Next, just have a look at the info. So everything should be in numbers. Please be careful. We do not need any non-number or non-numeric data. If you have a non-numeric data, you have multiple techniques to convert categories to numbers. So we have dot dummies function, or we have one hot encoding, or we have got transform function. Anything you can use and do it. Post that, if you look at the means, so if you look at the standard deviation and mean, again, the problem with clustering is, if in case you have a data which is highly clustered, that means it is compact enough like this. So if you want to create many clusters here, it is possible. Definitely we'll get clusters out of this, nothing wrong. But please be careful. There will be a lot of points on the boundaries like this. Yeah. So our first job is to find out whether the data is tightly packed or sparsely packed. Okay. So the first thing we can either check it from this, or we can check it from the means, or you can combine both of them. As per me, this data will be tightly packed. Just in case, if I put everything together onto one platform, you guys can observe that. Why? Because if you look at the standard deviation is almost similar. And if you look at the mean is also almost similar. Now, that does not mean that we'll not have extreme points. Definitely we'll have extreme points, but almost all the means are clustered here, and almost all of their standard deviation, let us say, is this. So we might have extreme points this way, something like this. Yeah. So that is the reason the first thing that we are supposed to do in any unsupervised learning technique, all the unsupervised learning techniques, is to normalize the data, or to scale the data, or to regularize the data. Any of the three means the same thing. Okay. I hope everybody is good with the scaling part of it, the basics. Okay. Guys, we know the scaling, right? Raju, Jyoti, Nitesh, Ramesh. What is normalization? And
Yeah, maybe you can.
Yeah, that's a Z-score, right? Putting the Z-score in.
Exactly, the Z-score, yes. Yeah. So on web, you might find certain bloggers who are saying we regularize the data. Some of them will say we normalize the data, and some of them will be very, down to earth, saying we scale the data. So all three mean the same thing. Okay. So I don't think we have not done, like, we don't know what is regularization. So
To get a better result, right?
Sorry.
So the scaling is to get a better result.
Exactly. So I will say not get a better result, but I will say that, how do you say that? For example, let us say you have got, you have got 3 kids, for example, and you are babysitting these 3 kids. Now there are chances that when you're focusing on one of them, the other one might, move out. When you focus on this one, this might move out, something like that. So here, just to take care of the situation, what do we do is, we first of all put a center point. We say that our data point will come to center. So not all the data are center oriented. If you plot this data set, it will look something like this. So when we do normalize the data, what we do is, first of all, we bring the scale here. We put the center here so that we are sitting exactly on the center. And then what we do is we put a barrier against the points, saying that everybody come closer, don't cross this barrier, basically. So this is what we do. So now we are assured that no data point is going beyond this. Yeah, this is why we do our normalization. If you want more examples today, I will show you why we need normalization for ML, why we need normalization for AI, why we need normalization for image processing. We'll take it up at the end of the session. Yeah, we'll go deep into this. So next is, so the first thing that we are doing is the Z-score or scaling. So post scaling, the data will look like this. So some of them are not comfortable. Some of my batches get confused. Okay, why do we have negative numbers and all? Please remember one thing, we are not changing the original values. The original values will remain same. How? If you look at the total standard deviation and mean and all, it's not going to change much, except we are changing the axis. So originally it was here, now it is here. So imagine the points earlier which were here on positive axis, post scaling they will come on negative axis. That's the reason you will see some negative points. So don't worry about that much. Yeah. Next is the way we find out number of clusters. Now, again, there are two ways to do this. The first way is when we come with a predetermined number. So let us say we just saw an example here where we're trying to classify cats, dogs, and rabbits. In this case, we already know that we need 3. You don't have to go into any other technique. Directly put k is equal to 3. So when you already know it, nothing wrong, you can do it. Else, if you want to know that as per the data set, let machine learning suggest us what is the total number of clusters we can do best here. Yeah. So in this case, what are we doing is very simple. Python will try to put the points like this. Let us say this is some points like this. Python will start, first of all, it will start with 1 cluster. It will say everything is in 1 cluster. Then it will say everything is in 2 clusters. It will record certain data. After that, it will say they are in 3 clusters or 4 clusters or 5 clusters. So like that, Python is going to record all the values starting from 1 going up to 10, for example, if you look at this particular plot. So this is my number of clusters and this is my distortion. Now, what do we mean by distortion is whenever there are 2 points which are confused. So if you remember in the example that I gave last session where there is a pizzeria and there are some points which are equidistant from this also and equidistant from some other cluster also. In that case, we call this as a distortion. Sometimes it go here, sometimes it go here. So keeping those distortions in mind, when we plot, so when we start with 1 cluster, we get certain distortion. When we go to this, so when we start increasing our cluster size, number of distortions might go lesser and lesser. But we cannot have 9 clusters. It's not okay for me to have 9 clusters. I'll tell you why. For decision tree, do you guys remember? When we have decision tree, what is happening? Always there is an overfitting for sure. Why? Because the decision tree was made deep. Last time when we saw decision tree, we had around 11 levels of decision tree going around and multiple levels of nodes. So when we classify as per our convenience, there is a chance of overfitting. So when we over-classify also, there is a chance of overfitting. So if you look at this curve, you will definitely feel that number of distortion is least for this. So my answer of K should be this, not at all. We are supposed to find out a particular point where the distortion abruptly goes down. So we call it as an elbow curve. We will find a curve like this, that is our K value. So if you observe here, there is one elbow like this, there is one elbow like this, and there might be one more elbow like this. Remaining all of them are kind of straight. So one of these will be our optimal points. Okay, so what I do is, I check with this also, I check with this also. Now again, I say it depends on our need. If you need 4, do it 4. If you need 3, do it 3. 2, do it 2. Nothing wrong with that. Now, how do we generate this plot? Very simple. It's like we are having a range defined from 1 to 10. So basically from 1 to 9. 10 will not be calculated. And we are keeping mean distortion as an empty list. Yeah, we'll store this mean distortion one by one. Then we are running our for loop 10 number of times. Okay, saying that start k-means or perform k-means clustering. How did we get k-means? K-means we have got from our, where is our library? Where is our k-means library gone? Yeah. So from sklearn.cluster, we have got our k-means library. So from there, we are saying run k-means on this data set with how many clusters? Clusters is equal to k. So the first value of k will be 1. So that's how we will get the distortion point here. Next, you are fitting the model, you are doing the prediction, and then you are calculating the mean distortion. Now, what is mean distortion? It's like, how do you say? Find the minimum number of points with respect to the distance on your data with the model cluster center. So if you remember, I said every time when modeling is done, one center is found. Okay, these are those centers. Euclidean distance we are using onto that. Okay, So using this formula, you can find distortion. Now, some of them even do RMSE, root mean square error, multiple ways you can do this. My method is using distortions. Good. Post that, what you do is you plot the curve. So when you plot the curve, obviously you can find out 2, 3, and 4 are my kind of possible clusters that we can go ahead with. Okay. Next, once you have decided how many clusters you want, let us say I have decided I want k is equal to 3. In that case, I will say, okay, here I put 10. Okay, just for show purpose, I think I have done it. There should be 3 here. So now my k is equal to 3. Now I'm fitting my data. Okay. Centroids. Okay, 1 minute. Yeah. So next, it is not mandatory for us to check the centroids, but just for our understanding, what I've done is I've generated the centroids. Now, if you guys can visualize this, I said if there are 3 clusters, there should be 3 centroids. Correct? Yeah. Each cluster will have 1 centroid. But in this case, what I'm trying to show you is we have got these many features. If you observe our data set, these are the features that we have. Yeah. Python is capable enough to build 1 centroid for each feature. Yeah. So if in case you want to reframe this, what we can do is rather than visualizing this way, see, it's not necessary to visualize this. Okay. This is just for our understanding I'm doing. If you observe here, simplicity, the centroid for 0th cluster is this. For first cluster is this, and for this cluster is this. If you want to find the total centroid of 0th cluster, what you can do? You find the average of this, you will get the center. Yeah. Now, some of them, why did I do this? Is just to show you guys that post, so this was my data before normalizing or before scaling. Post scaling, what happened was some of my data was up, some of my data went into negative side, and some of my data cluttered around the center. Read? You can observe the same thing here. You can find out 1 cluster which is completely negative. You will find out 1 cluster which is completely positive. And you will find out 1 cluster which is a combination of positive and negative. So the one which I'm showing here in the 0th one, this is your 0th cluster. The first cluster is this one. And the second cluster is the one which is centered around the origin. Okay. So this was just the reason to show you guys. Otherwise, we don't need to worry about this. You're just not making any impact on our answers anyway. Okay, next, let's generate our k-means. So this is our target variable. So these are our targets, 0s, 1s, and 2s. Why? Because we have got k is equal to 3. That's the reason we are having 3 targets. If my k was equal to, say, 4, as I said above, you will find 2, 3, 0, and 1. 4 targets. Got it, guys? So this is how you do your clustering. So let me change it back to 3. Okay. Now, next, what are we supposed to do? We are supposed to paste this as the last column. So what I'm doing now is I'm converting my labels as categories. Okay. Then next, what I'm doing is I'm joining my older data with my new data, and finally I'm displaying my data. So now if you see, our older data set had only these columns, the labels were missing. Now we have appended some labels. Now our data set is ready to be pushed onto some of the machine learning techniques so that they can build a predictable model out of this. If they don't want it, it's okay. If they want it, it's good. So our current business problem was what? That when the computer or when the person generates this report, automatically it should tell us what type of depression level it is. Either it's a very high level, mid level, or low level. Again, it is not necessary that 0 will be low level. No, you can name whatever you want. So post this, if you want to automate it more, you can write one more code saying that if label equal to 0, then change it to, say, depressed patient. Else, say not depressed patient, something like that. Whatever you want, you can label this 0, 1s, and 2s. Okay? Any confusions, guys? Yeah? Simple? Now, if you ask me applications of clustering, so from the industry point of view, now since all of us are almost a very high level or very high amount of experience, I will say use clustering majorly when you are onto marketing or customer segmentation, or if you have done an experiment, let us say if you have done an A to B testing onto a marketing campaign, in that case you can use clustering to solve your problem. Yeah, but some of us, let us say, who are a little innovative, and if you want to take a better side of this, if you find a data set without labels, put labels, push it onto machine. This is more popular. This one might not be explored that much. Yeah. So anybody here from marketing side?
Yeah.
Yeah. So Nitish, it's Nitesh, right, or Raju?
Yeah.
Sorry. Yeah. So what you guys can do is either you can use Tableau. Tableau has an inbuilt facility to do clustering, or you can use one of these to do clustering. Nothing wrong with it. Yeah. Perfect. So this was your unsupervised learning clustering.
And come up with the recommendation for each and every segment. It's not that you split the segment alone is enough. Right now, let us first see what is the data. So we have bank 515 records are present, and for each and every bank, what is the number of demand drafts taken, withdrawals, deposits. For take this as a time frame, I don't think for example, you take it as for last 1 month, right? The time is not given, right? What is the branch area in square feet? Average daily walk-ins, right? The number of people who are visiting the bank, either to take DD, either to take withdrawal, either to deposit the money, right? So branch area, if a bigger branch, it means that it can withhold the number of customers. If the branch size is smaller, right, then the transactions may be smaller. That is the assumption, right? So the branch area, whether it plays a major role or not, let us just do it by the clustering and verify. Import the libraries and load the data. I am importing the pandas scikit-learn cluster. Import k-means. K-means is present in the library cluster, right? Import matplotlib.pyplot. Right, in this this one, I'll just click this out. I'm creating it as data underscore df and check the data. To check the data, let us start with again our head to check the header of the data. So we have the demand draft, withdrawals, deposits, branch area in square feet, and average with daily withdrawals. And I'm checking the shape. And it has 6 columns, 515 rows. Like it is like dimension DAM command in R. Right now, data df, I've given the shape. Now we check the info for me. Right, we have all integers. Bank, DD, withdrawals are all integers. Right, and checking the summary statistic. Data df describe. So the average demand drafts taken is 232. Right, the 75th percentile is 291, and the maximum is 350. It's not more like it has an outlier. Right, I think here the average daily walk-ins is 657, whereas the maximum is 838. It has an outlier. Let us check the outliers also present. Right, to check the outlier, how do you check the outlier?
Box plots.
So it is present in Seaborn, right? Import Seaborn as SNS, right? So SNS dot box plot. X is equal to, I'm giving data df, right, and dd. Is there any outlier present? No, there are no outliers present in dd. And withdrawals, is there any outliers present? There are no outliers present. And as part of deposits, is there any outliers present? Right? There are two outliers present as part of deposit. We will find out for which bank that outlier is present and why that outlier is present. Branch area. Is there any literally very big branch? There is very small branch. Is less than even 1500 square feet. Very small branch. Right? We'll see how the segment falls for each and every branch. Average daily walk-ins. One has literally very high average walk-ins. Right? It could be either in biggest branch or it could be in the main of the city. Now we have to check for the duplicates. I think this header I didn't have it for the hierarchical. It should have been present there also. We have to check for the duplicates because they started lately after 2-3 hackathons. Once you start doing that, there will be lots of duplicate data that will be present. You have to remove the duplicates. Duplicated.
Sir,
Right?
is k-means affected by the outliers?
Sorry?
Is k-means algorithm affected by the outliers?
Yes, it is. Let us see what to be done. Duplicated. There are no duplicated. So I'm going to do one scaling. What happens if I have to do one scale? What is a scaling? What is a scaling? Scaling is nothing but z is equal to x minus mu divided by sigma. Do you agree with me? This is the formula for scaling.
Yes.
Right? Now, if there are outliers, will the sigma and mu get affected?
Yes.
Alright. Therefore, outliers should be treated. Outliers should be treated. That's a must. And what about missing values? What about missing values? Or there are 3 or 4 rules. Let us discuss the 3 or 4 rules before jumping into the k-means model. The rule number 1. Fill in the missing values. Fill in the missing values percentage. Right? The second one. Right? Remove the outliers. Remove or outlier, treat the outliers. And if the data is skewed, reduce the skewness. And fourth, if there is categorical data that is present, what should we do?
Should consider some other column and try to derive the value.
Okay, so you are going to remove the categorical variable.
No, as you know, if say for example there is a gender column and most of the data is missing, we may consider the name column and try to derive the gender.
Okay, that is one way. For no, you have all the data for the gender. right? I am not telling about the missing value. What happens when the data is categorized?
Can we use labeling and normal?
You have to do the encoding, label encoding or one-hot encoding. That depends, right? You have to label the data. Whenever there is some categorical data, we have to label the data. Else there is no point in, because this all take the distance measure. If it is categorical in nature, how will it take the distance? It does not take the distance because the value, some x value or some y value, some numerical data has to be present. So if I encode it, then it is a different. Then fifth most important thing, scale the data. Right? Why should I have to do this scaling? Why should I have to do this scaling in the first place?
If we don't do the scaling, one particular column having more value may affect
Perfect.
the distance.
Perfect. Right. So I'll give some names mention it as a rules or I'll put it as data preparation. This that's not in rule. That is in data preparation. Right. So we have to create. The data must be scaled. Oh, here and right. Okay. So because the withdrawals are in different units, this deposit is in different units, the branch area and square feet is in different units. Okay, this too you can have it as a count. What about it is? What about this? It is a completely different unit. 2460 and 111. You cannot compare this to age and salary. Very classic example. What is the age of a person and what is the salary of a person? If you have to run a regression, right? It shows some nonsense value. So you have to scale it and bring them all to the same units. How do I bring them all to the same units? That is our way, very old traditional way, using the standardization technique. We call this system standardization. There is one more way to do it. What is that called as?
Min max value.
Right, this standardization. The other one you can also use for the min max scale. Right, here we are going to go ahead with the standardization technique. Scaling. We are going to take a standard scaler. How do I have to take the standard scaler? Which library has the standard scaler? From
Z-score.
where?
Z-score unit.
Okay, Z-score. I want to use the standard scaler. Pre-processing. There are various ways of doing it. Import, right? Standard scaler, right? Scale. Okay. Now I have to create an object. Whenever I call a function, I'm creating a function for the standard scaler. Right? A function should have the double brackets. Right? Once I've created the function, now I'm creating x dot fit and transform. I'm fitting the data and transforming it also. Transform what? The data df, data df dot ilog. Okay. Data df. I don't want this blank. 1, 2, 3, 4, 5, 6. Okay, I give it all. Right. So I'm giving it all. I'm fit and transform all these data points. What is this? First, I'm fitting. And transforming it. I'm transforming using the function standard scaler. It's not only fit here. It's fit transform. And I create a new object scaled data set.
So can you explain the difference between fit and fit transform again?
So see, for example, should ensure the solution file. 1 second. If I have to use the k-means, right? If I give the k-means, I'm only going to fit it. I'm going to use the fit function. I'm not fitting and transforming it, right? If I give that k-means, right? If I am going to call from the k-means library, I'm going to take the k-means function, right? From the scikit-learn, the cluster, right? I have taken the k-means function. If I have to, in the k-means, if I want to run the k-means function, I'm just fitting the algorithm. I'm not transforming it. Right? Or last week I had a good material to explain also. 1 second. Yeah, please tell me.
I'm just confirming, like transform means that it will replace the current value.
Perfect.
Okay.
It will replace. It will transform the values. I forgot the right term. I have noted it down last time. What is the transform? Alright. I'm sorry. So I'm just whenever I want to whenever I give the standard scalar kind of a function, so I'm converting the data, new data, right? Applying this formula, the standard scalar, and I'm transforming it to a new data, right? So now I haven't scaled the data set. Okay, it is an array. Okay, now I'm creating in clusters using k-means. Now I'm creating in clusters, forming two clusters with k is equal to. Create k-means cluster and store the result in the object k-means. How do I do it? I've all created the hint, all the hints. I think this hint should also be present with some worked out thing also will be present in student. But I always tell them not to have it. Right. Now create k-means cluster and store the result in the object k-means. K-means I've created an object. How to run the k-means right now?
K-means n underscore clusters.
Cluster is equal to 2 clusters n underscore clusters. Yes, I think so. Okay, n clusters. So I'm creating 2 clusters for this k-means and fit the k-means in the scaled k-means dot fit. I'm not fit transforming here. Fit scaled It has created me 2 clusters. By default, it has taken n initials to 10. Right now, let me get the labels for it. K-means So how many clusters did I give? 2. 0, 1 are the 2 clusters that has formed. 0 and 1. These are the 2 clusters formed here. Right now, I have to check the within sum of squares. What is the within sum of squares? As a recap, how is the within sum of squares calculated?
K-means dot inertia.
K-means dot inertia is right. How is it calculated? I'm telling about the formula. What is the understanding of this? So in any cluster,
To centroid distance.
based on the centroid. A centroid based on the centroid. Right? Different points. What all the points are present? The distance is calculated from the point. Right. So K means inertia. Inertia. So 1943.34. So what does the inertia mean? What is the smaller the inertia? What is the larger the inertia? Or what is the smaller within cluster mean? What is the bigger within cluster? Should it be smaller value or greater value? That is my question. Should the someone? Should the within sum of square value should be smaller or should it be bigger?
Smaller.
Smaller.
So smaller the inertia, denser the cluster, closer together all the points are. Smaller the value, denser the cluster. Right? So let me take for all the values. So let me have a preset value. K means is equal to K means n clusters S. Clusters is equal to 3. And what was the second step? K means I have to fit the tab. K means dot fit with what? K underscore means, right? And K means underscore inertia. K means inertia underscore. Inertia, somewhere some mistake, small mistake. K means
In fit, I think.
Fit, scale, data, it should be there.
I'm sorry. Scaled DF. K means any spelling mistake, can you find it up?
Inertia.
Okay. Inertia. Right? It is giving me again smaller the inertia. Right? As the clusters increases, your inertia value will decrease. Right? As the cluster keep on increasing, the inertia will keep on reducing. What is the right point? Where should we stop? Where should we stop? We have a visual proof. As the clusters keeps on increasing, the inertia value keeps on decreasing. The within sum of square reduces as K keep increases. Right? So what is the right value to choose? What is the right value to choose and how to choose?
Using WSS plot.
So using the WSS plot is nothing but we call this as an elbow method. Right? These small 4 or 5 steps in clustering. This clustering is very, very simple. But these are the late or wherever interview you go, these are the clustering. The clustering questions is what they're going to ask. Because the interviewer knows only about the clustering. In interviews over 4 to 5 interviews, they always ask me what are the step-by-step approach in clustering. Why should I have to do this scaling? If I tell something more, they may not be knowing it. So be confident with 4 or 5 steps. What are the step-by-step approach to do in clustering? Why in standard scaling? And similarly in classification, regression test, what is a classification? What is a regression tree? Right? What does a Chinese code do? One basic questions is what in all the interviews people are asking for. Right? I'm creating an empty file. Right? And I have a loop here. Right. So for I in the range of 1 to 11, right? 1 to 11 numbers I'm giving for K. K means just I'm giving the K means n cluster is equal to I. The I is nothing but each and every value it is going to try and is going to show it to me, and you append it into the KM inertia. Right now, if I give WSS, in the WSS it is going to append all the inertia values, and I have the WSS value here for the K values 1 to 11. 1, 2, 3, 4, 5, 6 up to 11 it is going to have. Now what is the command to plot? It is always plt.plot or plt.show to show the plot, plt.plot to plot it, right? The range 1, 11. All the values you show me in the WSS, right? For 1 to 11, show me all the WSS part. Now you tell me where and what to be used. What is the point? What is the cutoff point to be used? What is the cutoff point to be used here?
Four.
So 4 is right, 3 is right. So it is all based on the assumption. 3 can be used. 4 can be used. So at which point at 3 itself you can see that the bend is not seen, much bend is not here. Again here the much bend is not here. Again it is very little bend that is shown here, right? It is again up to your own choice, right? Which maximum variance, whether it is 4 or 3, it is your choice. It is not an hard and fast rule. There it is not at all an hard and fast rule. You can either go with 3 or you can either go with 4, right? It's up to you, right? By default, where the maximum variance explanation is reduced, you're going to select that point. From first, the second, how much percentage of variance? A big amount of variance has been explained. The 2 and 3 maximum variance is explained. After this 3 and 4, very small distance you could see here. A bigger distance here, a very big distance here. The amount of variance explained by each and every cluster. The smaller variance that keeps on explaining, we do not want those clusters. We do not want to waste our time. Only the maximum clusters explained, maximum variance explained by the cluster, we are going to pick that only. Right? Again, there are a number of plots. If we could use R, right, F visualization, Silhouette plots. Number of plots will show you the NB cluster. Again, there are a number of ways the selection of right cluster is present. The elbow method is one of the method. I'm just giving one example. This elbow method is just one of the method. If you could Google and do some R&D, you try to do the real-time projects, this information is not enough, not at all enough. There are a number of methods. The WSS is one method, a Silhouette score, and there are many number. NB cluster is very famous. So K means, I'm taking my default K means is equal to, K means with K is equal to 3. Just to understand how clustering works, what is the recommendation that we could give, right? These are small things that I'm going to tell here. Now K means with K is equal to 3, right? Now I want to take the labels out of it. How do I take the labels out of it? Where is that K means is equal to 3? So let me take this thing. K means is equal to, with the cluster is equal to 3. I do not want to know the inertia value. Right now I want to know the labels. K means labels. So I think I understood it. Okay, I'm sorry, one second. K means any cluster is equal to 3. K means dot fit.
K means dot label.
K means dot labels. Yeah, sorry. K means dot labels. LAB, spelling mistake. LAB. Labels. So I'm referring all these labels to a variable or an object you could call labels. Right? K means with K is equal to 3. Now let us just evaluate for this cluster for using a Silhouette score. What is the Silhouette score for the cluster with K is equal to 3? Right? For the Silhouette score, which library should we take? From sklearn. So you do not have to by heart, but you should know little. These are the basic things. Import silhouette samples, right, and silhouette score, right. Right. So just I wanted to show some spelling mistake should be there. HOE. Yeah, forget it. I have it already here. Right. So in the matrix, scikit-learn in the matrix, import these functions silhouette samples, silhouette score. Right. Now how should I have to calculate the silhouette score? Straightforward, I could use this function silhouette score with the scaled data frame and the labels to show me the silhouette score. My silhouette score is 0.2187. It's literally very less value. Now, as you people said, it is check for k means is equal to 4 also. Right, and cluster evaluation for 4. Silhouette score. This pulling score and 0.22, somewhat relatively better. Right. Again, if you keep on increasing, right. It keeps on increasing, but it isn't very marginal, right? 0.2297. There is a point. It is dropping. The silhouette value is dropping, right? You can keep n clusters is equal to 5 because after this point the silhouette score seems to drop, right? So just by, it's not like only elbow rule. We have to take 2-3 metrics and combine them and select the right cluster value. Because when it comes to real-time projects and all, right? So it's not like the assignments that we are submitting here. So you need to validate each and every cluster. Why have you split this cluster? Your management is not going to understand. It is just you're just taking Tableau and you're just plotting this values and you're giving. What is the reason? What was the evidence that you have split this cluster? You have to prove to their management. These are the ways that I have tried, and because of this so and so value, I have selected the number of clusters. You have to prove to your client or prove to your management, right? So one way that elbow nobody is going to understand. So that highest variance, why is the remaining variance is not selected? So there are various metrics. Combine all these metrics, right? And then you give a good value. And right, and I have to profile the clusters. Data df, and I'm creating labels. With what? Labels. Labels is the name that I have created. Labels. Right. Now data df dot head. So I have an labels created as an additional column. Right. Now I have to do the customer profiling. Profiling is very, very important. Last, what does each and every cluster tell me? Here we create, this name is different. I create this labels, value counts, and sort the index, right? And then you're going to create the profile the customers over here, and the cluster profile. Right. So for different clusters, what are the values? I have taken the average value. Right. I have taken the average value, mean value for all the observations present. There are 146 observations present in this cluster 0, the first cluster. 139 observations present in this label 1, 132 observations in this label 2, and 98 observations in this label 3. And I've taken average DD value, average withdrawals, average deposits, average branch square feet, and average daily walk-ins. Right? Now, what could the conclusion be? Cluster 0. Right? I've created the recommendation for the 4 clusters, even though the 5th cluster has a silhouette score of higher value. I've created a recommendation earlier for the preparation of the class. Right? So let us discuss that. What could I tell? Cluster 0, small size bank with less deposit. Bank is smaller. Why? Cluster 0 is small size bank 3020 with less deposit but highest walk-ins and withdrawals and the largest DD. One second. Sorry. We could just discuss this. This was the output. The cluster names are varying because my seed value is different. Right now, we could, based on the cluster 0, it is small bank. Average bank area size is very small with very less deposit. Deposits is very smaller, right? But highest walk-ins. Walk-ins are literally the highest. And withdrawals is also relatively larger in number and larger deal. Right? What is the recommendation that you could give here? What is the recommendation that you could give here? For the cluster 0, the size is smaller and bank size is very small. It could be present in very peak area. What is the recommendation that you could give here? What is the recommendation that we are likely to give here for the cluster 0? It is a small size bank, very small deposit, but the walk-ins are very larger in number. Withdrawals are also very larger in number, and large deposits are happening. So we could focus on their infrastructure and the banking facilities. The area is smaller as compared to the remaining cluster. You could focus on the infrastructure. Your bank size is smaller in size. You focus on the infrastructure. Then the cluster 1, it's a medium-sized bank with less walk-ins and deposits and high withdrawals. It is relatively somewhat bigger in size comparing to this 2 other cluster 0 and cluster 2. Right? With less walk-ins. Walk-ins are relatively smaller in number. Right? But withdrawals are very larger in number. Alright, here also, since the bank infrastructure, they could focus on the infrastructure facilities and the banking facilities, right? Because it is smaller than the rest 2 clusters. Right, so that one, okay, let me just open the recommendations directly instead of my own assumptions. Yeah. So the banks in cluster 3 has higher DD and withdrawals. Right, withdrawal is very larger, right, and DD is also very larger in number, but very less deposit. So it needs to improve in making the customer deposit more. So relatively large number of customers are visiting the banks. So improve the various deposit schemes to these customers. So this is the recommendation as a data scientist that you do. So even when you do your submission of your assignment, whatever you do in the previous steps, it's okay, but the recommendation has to be stronger. That is where your marks lie in. That is where in real time scenario also this these are going to add much value. So customers in cluster 3 seems to prefer payment through DD because the larger DD number is here, has a record the highest DD rate. Banks can check if the DD is being made to other in the same bank. Whatever the techniques. Sandeep, you wanted to tell something?
Question before coming to the conclusion, like recommendations. Like if we look at the means, like we have to take into consideration the outliers, right? For example,
Yes. Here there are only 2 or 3 outliers, so I just ignored it. But it should be addressed.
okay, so my question is, because there are outliers in deposits, branch area and then average daily walk-ins. So in the end, when we conclude, we are using the mean here, right?
Yes.
So shouldn't be a problem. For example, there are outliers in branch area, right? When we say that cluster 1 is a small branch or like large branch, so wouldn't it be a problem because there are
Yes.
outliers?
It should be addressed. It should be addressed. That's what I noted it down. These outliers should be addressed, right? So just for the classroom purpose, I'm trying to tell what are the recommendations that can be given based on these conclusions.
Okay.
Some generic conclusion value that I'm trying to tell.
Okay.
Right. Here, one or just a basic outlier. It's not like falling very much out. So 1 or 2 points were there. So only 1 point were there. All right. So that to 800 to 820. So I thought like, why to treat it? Else you could cap the value. Anything greater than 800, you can fall it up to 800 itself. You can do the capping value. If it is 810, right? Anything greater than 800, you make it as 800. Capping can be done. Value capping can be done. You're right before addressing it, but it is going to marginally change the values. I've taken the mean value, marginally it is going to change, but definitely it's going to change. All right, Sandeep. But
Yes,
when you're going to when you're going to do your project, please check for your outliers, missing values, all the step-by-step approach, and you do it. So again, the customers preferring DD can go to banks either in cluster 3 because they have really very good DD section. It could be like very good DD section could be placed in the cluster 3. People whoever wants to take DD, they are preferring that bank rather than the some other banks, right? Because they are giving preference for this DD here. Like it could be something like that. Like deposits are again less, while withdrawals are much higher for the clusters 1. Right? Withdrawals are larger, but the deposits are relatively very small. Right? So these banks can also look at introducing the new deposit schemes. So these are all some generic recommendations. So when you're going to do a business report, it should have an end-to-end like this, right? So a marginal outlier, you either cap it or address the outlier, right? Before jumping into any clustering, you fill these steps, right? Filling the missing values, treat the outliers, reduce the skewness. You cannot avoid the skewness. That is impossible. Reduce the skewness. What happens if it is a categorical data? Encode the variable, right? Scale the data. Right? These are all very important things to be addressed, right? So I think the steps are very, very small. These are the 4 line steps, right? K-means, N cluster, and it literally only these are the 3 lanes that to be taken into consideration. If you are going to run 1,000 line programs, if you're going to go and K-means, only these 3 lanes you are going to take it into account, right? And you're going to take in single out score, and you're going to take it. Less than 5 to 6 line, like we did for principal component analysis. So even before doing this K-means, you have to check for the principal component analysis. So all those step-by-step procedures will be coming. At last, we'll have an end-to-end session. After what should be done, after what this step, what should be done. We will have an end-to-end session. Right now, as part of understanding what an k-means is doing, what is a step-by-step approach that an k-means to be done. So that is what has been shown here. So, and we have created an labels based on the values, and we have done an customer profiling. We call this as a customer, the cluster profiling. So we call that as a cluster profile. Profile the customer clusters, right? And based on the profile the clusters, we give the recommendations, right? Is there anything that is very much complicated here? The doubt raised was based on the elbow rule. How will I come up with it? So elbow rule and the Silhouette score, right? The one other metric is also there that wasn't covered. You check NB cluster. NB cluster also can be used, right? Since it was not there in your curriculum, I do not want to confuse. NB cluster, you can try that, right? And so only these three things, if you could do, you could address this clustering problem, right? It was only 500 data points, so it was very easy to explain. For classroom purpose, it's okay, but in real time, if you're going to deal with millions of data, then the challenge comes into. Right? So, any other doubt, guys? Any other doubt as part of it? So I have noted down one more point also. That it's not so like I've created in step 1, step 2, and step 3. I don't know how much. Step 1, assign one cluster. Assign one cluster center at starting, and you keep on adding it, right? You do not have to know where the cluster should be placed. Anywhere, if you give k is equal to 2, where will the cluster placed? If you give k is equal to 2 in cluster, where will it be at first? If let me put it like this. There are so many points. If I give k is equal to 2, where will the two centroids be? Can it be over here and here? Is there possibility? Guys?
Minimum distance there should be there.
What is that minimum distance? Why can't two clusters be like this? These are two clusters, or consider this red as one cluster, and this is one more cluster. Can there be two clusters like this? It can be. It can be. When you're going to start, and these are the data points that are present, right? And if you're going to give k is equal to 2, the clusters can start up with any point. It can be here and here, right? Any data points near to it, it's going to collect. Any data points near to it, it's going to collect. And the cluster, the centroid will change. Based on the distance method, the centroid will change. And based on this, the centroid will change to this. And again, the distance measure will be calculated, right? So the centroids, the initial centroids can be anywhere. Based on the distance meter, it keeps on reallocating. The centroids keeps on changing. Right? So it keeps on changing. So the initial cluster is placed randomly, can be closer like this also. If it is anywhere, these are all the data points. The clusters could be any, and it could be like very close to each other. Right? It is the k values are generating by itself. Right? Compute the distance between each cluster. Okay, I don't want to confuse again. This has a different approach. I should have filled it earlier. Forget this. Right? The k values can be anywhere closer to each other. It does not matter. So each and every time it is going to iterate. It is going to calculate the distance, and it is going to reassign the centroid value. Right? It keeps on reassigning the centroid value. When the maximum distance between the intra distance is achieved and the intra distance is achieved, minimum intra distance and the maximum intra distance is achieved, that is where the cluster stops reassigning the centroid. All right. So do you have any doubt here, guys? As part of
So
k-means? Yes, yes,
one question.
yes.
So in sellout score,
Select
after we change cluster value to like more and more, the sellout score decreases. So how, like with that, what can you infer from that
one second.
sellout score? Like
So
in
this
K
is
means, like smaller the value, denser the cluster would get. And in
okay.
sellout score, does it
Skill out
imply the
score,
same?
anything closer to 1, the value is good.
Sir?
Closer to 1, closer to 1. It should be closer to 1.
Okay.
Silhouette score has a value like -1 to +1.
Oh, okay. Ah, yeah. Okay. Yeah.
Right? Anything closer to 1, the silhouette
One.
score is better.
Yes. Okay. Yeah.
Right?
Thank you, sir.
Okay. So as part of when you're going to given project, if the project comes in clustering, please give good recommendation and do the k-means. That's it. It's not so difficult to do. K-means is very simple thing to do. Right? You do within sum of squares. You understand what that within sum of square does, what does an silhouette score does, right? And what does an elbow score does. That's it. The concept is done. Right? Once you get into the random forest, whatever is like once you only what can I tell you? Only when you start keep on working on that day in and day out, you can understand the depth of each and every model. We can simply tell Euclidean distance it is calculating. What are the major challenges? Simple challenge. What happens if there is a categorical data? That is a challenge. How are we going to scale the data? That is a challenge. So once you keep on working on the models, then the complexity is also increasing and you'll get experience. Right? All right. So any other doubts, guys? So other than that, we are done with this session. If there are no doubts, then we are done with this session. Any other questions?
Sir.
Yeah.
So, like you said, the Szilard score is closer to 1, then the mapping is correct.
Mm-hmm.
And if it is negative, then mapping is wrong.
Completely wrong. Completely wrong.
So
It usually it usually starts from 0 to +1. If it is -1, then it is completely wrong. Then we have to check for any outliers. Is there present something?
Okay, then okay, we have to correct it by checking for outliers and missing data and all those things.
Somewhere our assumptions are missing.
Okay.
Yeah.
Start. In this session, we have learned about k-means clustering and its hands-on in Python. So if you want to learn more advanced topic like this, please go to our Great Learning Academy platform where you will get almost 80 plus free courses, and after complete your course, you can claim your certificate as well. That is also free of cost. And if you want to do the courses in the mobile application, that is also available in Great Learning app. Thank you so much.